Hello, dear students. Today I have to explain principle of superposition for electrostatic. According to this principle, force of a interaction between two given point charges. I repeat, force of interaction between two given point charges remains unaffected when the other point charges are placed near them, and accordingly the total force on a given point charge due to any number of point charges is the vector sum of the individual forces exerted on the given point charge by all other point charges. I repeat, according to principle of superposition, force of interaction between two given, I need to say interaction means it may be attractive force or may be repulsive force. Force of interaction between two given point charges remains unaffected when the other point charges are placed near them, and accordingly the total force on the given point charge due to any number of point charges is the vector sum of the individual forces exerted on the given point charge by all other point charges. Now I can explain in detailed form. Suppose there are so many charges. Suppose this is charge Q1, another charge is Q2, next is Q3, and suppose this is a Q4. And here is a test charge. Test charge can be represented by Q0. Q0 is a test charge, and position vector of test charge from the origin is R0 vector. Similarly, the position vector for the Q1 charge is R1 vector, and similarly position vector for Q4 charge is R4. This is Q4 charge, and position vector for Q2 is R2 vector, and position vector for Q3 charge is R3. Okay. Force applied on test charge by Q1 charge. Suppose Q1 is positive charge and Q0 is also positive. Test charges may be positive. Okay. Now the force exerted by this positive Q1 charge on the test charge is repulsive, and the direction of this force is this. This can be represented by F, force on test charge 0, 1 by one charge, and the position vector is R0, 1 vector. Similarly, force applied by, suppose Q2 is negative charge and Q1 is positive charge. Okay, then force applied by Q2 charge on test charge is attractive, and the direction of this force is this, and this can be written as R0, 2. Okay, and similarly force applied on test charge by Q3 charge is, Q3 is positive charge, then the direction of this force is this. It is F0, 3 vector, and the position vector is R03. And similarly, force applied by test charge Q4 on test charge is this, and this is also positive charge, so this is the repulsive force, and applying in this direction, F 0, 4. And the position vector is R0, 4. It is a very complicated figure, so be careful. Now we can calculate force exerted by Q1 charge on test charge is written can be written as 0, 1 in a vector form. In previous class, I have to explain. I explain in the vector form of the force is F equals to K Q naught Q1 upon R 0, 1 mode square, where K is small k is a proportionality constant. It is equals to 4 pi epsilon naught. Okay, and then vector form is can be written as F0, 1 cap, and R0, 1 is equals to, look here, this is the R1 vector, this is R0 vector. According to triangle of vector addition, vector R1 plus vector R0, 1 is equals to R0. So R0, 1 is equals to R0 vector minus R1 vector. So modulus of this vector is R0 minus R1. Okay. So we can write here R0 minus R1. Clear? So F01 is equals to Q0 Q1 R0 minus R1 cap upon 4 pi epsilon naught R0 minus R1 square. This is the force applied by Q1 charge on test charge. Similarly, F02 is equals to Q0 Q2 and here R0. Look at here. For the Q2 charge, the position vector is R2 according to triangle of vector addition. R0, R2 is R0 plus R02 is equals to R2. Here R0 plus R02 is equals to this. According to triangle, this is the resultant vector. This vector equals to this plus this. So R2 is equals to R02 is equals to R2 minus R0, and this can written in the form of minus R0 vector minus R2 vector. Okay, so we can write here in this format minus R0 minus R2 cap upon 4 pi epsilon 0 R0 minus R2 square. Similarly, for F3 is equals to Q0 Q3 R0 minus R3 upon 4 pi epsilon naught R0 minus R3 square. And for R4, F04 is equals to Q0 Q3, Q4 is also positive charge, R0 minus R4 upon 4 pi epsilon 0 R0 minus R4 square. And up to similarly is F0n. Up to n charge, F0n can be written as maybe positive, maybe negative. It is depend on the nature of charge. For nth charge, plus minus q naught qn upon 4 pi epsilon naught r naught minus rn square, and here r naught minus rn cap. Okay, these are the forces exerted by individual charges. And then according to superposition principle, we can write net force F is equals to F01 plus F02 plus F03 plus F04 up to plus F0n. Putting the values of F1, F01, F02 by from this side, so we can write F vector is equals to F01 values here. In this case, in all expressions, Q naught is common, so we can write we can take common Q naught, and 4 pi epsilon naught is a common. So next is Q1 R naught minus R1 cap upon R naught minus R1 square minus, here is negative sign, Q2 R naught minus R2 cap upon R naught minus R2 square. And similarly, it can be written as up to Qn R naught minus Rn upon R naught minus Rn square. So in short form, we can write F vector, F net force on a test charge is Q naught upon 4 pi epsilon 0, and summation of these forces Q integer I R naught minus R integer upon R naught minus R integer square, and integer I from 1 to I equals to n. Okay, this is the format of superposition, net force applied by the all charges on test charge. It is called principle of superposition. Now let us take an example related to superposition principle. Suppose a hexagon has side of this hexagon. Okay, this is the center. Each side of hexagon is L, and each angle of hexagon is 60 degree. That's why total charge, 5 charges are situated at the vertex of hexagon, and all are positive charge, and 1 charge has negative nature situated at the center of the hexagon. Now find the total force on test charge, minus Q at center O. Suppose this side is A, this vertex is A, B, C, D, E, F. According to superposition principle, this is positive charge, this is negative, and attraction force acting in this direction, and similarly the acting force this charge, positive charge, attract negative charge in the direction of this force acting in this direction. Then these two forces are cancelled to each other. Similarly, QA charge attract to test charge, and QD charge attract to test charge, and these are also cancelled to each other. then the force, total net force applied on the test charge can be written as F is equals to K Q into Q. Here is the magnitude of charge, that's why we cannot take sign of the charge. And length of the side is L, because this side, the hexagon has L side, and this is also L, this is also L. Each angle is 60 degree, that's why each sides are equal. So it is L square. The magnitude of the force on test charge is value of K equals to 9 into 10 to the power 9 Q square upon L square. Now the net force applied on negative charge Q, which is situated at the center of the hexagon, is equals to 9 into 10 to the power 9 Q square by L square Newton. That's all for today. Now next class we have to discuss distribution of charges. Thank you very much.